Hello everyone, this is my extra credit for the proton acidity for test 2, and the first thing you need to grasp is that the strength of the acids depend on the stability of the conjugate base, and the conjugate base, or how stable the conjugate base is, depends on these 4 factors. And then it has some practice problems here so we can see these in action, but let me just go down the list. So the first one is size, like how big is the electron cloud. Second one is the electronegativity of the atom itself and the neighboring atoms. And the fourth/third one is resonance. So let's just go through these practice problems. So hydrogen or hydrofluoride versus hydrosulfide. So this is an example of like a size question, and you can see that the size of the conjugate bases fluoride or fluorine and sulfur are different. Because fluorine is in the second period, it means that the electron cloud area is small compared to sulfur's large one because it's in period 3. And a larger electron cloud or size means that the electron charge or the negative electron charge is more spread out across the atom, meaning that it's more stable in turn. And since sulfur is a more stable conjugate base, that means hydrosulfide is a stronger acid. Moving on to the next question. This one is an example of electronegativity depending on the atom itself. And let's first try to draw the Lewis structure of the atom. You generally want to do this so you can get just like a better understanding of the situation. And it'd be really helpful for the next 2 example questions. So these 2, sulfur and chlorine, are in the same period, meaning that you cannot everything in the same period means that the size difference is pretty negligible and you can just ignore it. So instead of looking at the size difference, you need to look at the electronegativity of sulfur and chlorine and then compare them. So the electronegativity of sulfur is 2.58. Let me write that better. Versus the electronegativity of chlorine, which is 3.16. And 3.16 is obviously bigger than 2.58. So that means chlorine is more electronegativity. I'm not sure if that's a word, but that means that chlorine can handle electron or a negative charge better than sulfur, and that means that it's more stable, which in turn means that the hydrogen chloride is more acidic. Move on to the next question. This is an example of electronegativity and comparing it to its neighbors. And let's draw the Lewis structure. Let's draw the new structure of the conjugate bases. So here you can see that the negative charge is on the oxygens, so you can't really compare the electron activity of those 2 atoms. It'd still be the same. So you can compare the atom that's connected to. So let's write down the electronegativity of, this should be chlorine. Chlorine, so the electronegativity of chlorine is 3.16, and the electronegativity of nitrogen is 3.04, which means that chlorine can handle a negative charge better than nitrogen, which means that it's more acidic, or be more acidic in this scenario. And then let's just move on to the last question. Which has to deal with resonance, and draw out the Lewis structure of the conjugate bases. Let me draw this a bit closer over here. So we can see that the oxygen each have the negative charge again, but the connecting atom is like the same atom, it's carbon, so you can't compare the electron activity of the neighboring atoms again like we did in this previous problem, so it would be the same thing. So this problem we have to look at the residence, and in order for residence, or in order for atoms to have residence, it needs to have three atoms or connecting atoms. And within those three connected atoms, it needs one multiple bond or sigma bond. So it requires one sigma bond in those three connected atoms and one set of lone pairs. So there's no three connective atoms in this one, so it has no residence. And for this one, we can see that it has three connecting bonds. It has a sigma bond here and a lone bond here, so it would go 1, 2, 3, where this bond would turn into two lone pairs, and these two lone pairs, or not two lone pairs, but one lone pair, and this lone pair would turn into a bond, forming a structure that looks like this. I'm just going to draw it over here. With the negative charge now being in this oxygen. And then we can see another one, we can do more residence, which of this one, with there being a sigma bond here and a lone pair here. So it would be 1, 2, 3, with this bond becoming a lone pair, and this lone pair becoming a bond. And then you can do again, so I'll just drop the other two. That's supposed to be, let me write that over here so you can see the negative charge better. And then you do the same process over here to get this loose structure, this residence structure. Oops. And then when you combine all these to form a residence structure, it would look something like this. And I'm going to have a partial charge. Since the negative charge is dispersed over all four atoms, it would be 1/4. That would be its partial charge. And since this one, the negative charge is dispersed over one atom, it would be 1. And since this one has a lower negative partial charge, it means that it's more stable. And if this conjugate base is more stable, it means this acid is more acidic. And that's about all the problems. So you can see how I'll just do a quick run through again in case I did pretty bad explaining, so I'll try to do a quick run through. So for size, it depends on the conjugate base, and the conjugate base depends on the period number, the element in. So, like the example over here, fluorine and sulfur. Fluorine's in period 2, sulfur's in period 3, so this one would be more acidic. Second one, electronegativity of the atom. Yeah, basically these are in the same period number, are in the same period, so you would need the electronegativity of each atom to see which one is more stable. And fluorine is more stable or had a higher electronegativity than sulfur, so this would be more acidic. This one you need to, or for the next problem, you need to see the electronegativity in neighbor atoms. So the sulfur or the oxygen had negative charges, so you need to compare the atom or the electronegativity of the atoms that are connected to the oxygens. And chlorine would have had a higher electronegativity than nitrogen. And then for the last problem, you need to use resonance structures to find out the partial charges, so you can see how stable the conjugate bases are. And then whichever one had the lower negative, like a partial charge, would be more stable, which then had to be hydrogen, or yeah, this one. So sorry if I did a pretty bad job explaining it, and have a nice day.